This is a note for myself really, but maybe useful to other people. This is an Epson 2500 EcoTank printer, which is great. I've really found it good. However, although I've filled the tank several times, probably well 3 times, I guess, not that many, but it has failed because one thing, the print head has got a blockage which it won't clear, so it prints a black, a missing line as it prints. But more to the point, it's actually stopped working completely. And having looked it up online, it turns out that there's an inbuilt timer in effect, or it's a print counter, which stops the printer working when the sponge is full. And this is the sponge, having taken it apart. I'm obviously not going to repair this. I just wanted to see how this thing worked. But basically, there's this sponge unit which is full of sponge, would you believe? But it actually, I've broken it getting it out. It actually clips into the bottom of the printer. And there's a screw here in this particular version. So this is the underside of the printer. And this has a very ink-covered rectangle here. And this sponge unit just fits in there. It's got a little tag on the edge here, which engages with the plastic. And there's also a little catch on this side. Once it's in, there's a screw on the back. So this little area here on the underside of the printer, took that screw out, you could remove this and presumably replace it. Interestingly though, that this little drain here, which remember is this way up in when it's working, has actually got a tube coming from it, which goes down here and ends up in this little gadget here, which is where the print head parks. So somehow, again, this looks like a sponge, but it's obviously got a special seal around it and this metal profile. So once the head unit parks, it obviously parks over that and presumably seals against this rubber seal around the edge. And any ink draining from there somehow gets sucked up this black tube and is dumped into this sponge cartridge. It is effectively a cartridge. And so there's some sort of timer or counter that trips out once this sponge is deemed to be full. There is software online I've found that lets you reset the counter. It sort of overrides the Epson firmware somehow. You have to pay for the privilege, but you can reset it and get the printer working again. But I guess if you were to do that, then you should probably clean out this unit first, or better still, replace it. So I assume that's what the Epson Service department would do if you were to go to them. But it would be feasible, I'm sure, to remove this sponge cartridge, either rinse it out or flush it out, dry it out, whatever, replace the sponge with something else. Use the firmware override software if you chose to, and get the thing working again, and have somewhere for the ink to go into the sponge. Anyway, I've actually bought another one of these. It's a more up-to-date version now, 2810 I think it is. But next time I get the same problem, which will be in a few years' time, this one took about probably 8 years, given that we don't print very much, to reach the point where it wouldn't work anymore. If that happens again, then I will know now to look for this cartridge underneath, maybe change the sponges, maybe use this override third-party software to reset the counter and hopefully get the thing working again. Okay, so dismantling this a bit further, this unit comes out, which is the piece that the heads rest on as they're parked, and it's actually sprung loaded. There's a spring under here which keeps it pressed against the underside of the printhead. But there's a drain here on the underside. There's a little drain there which connected to this tube, and amazingly the tube passes through here, through this motor, and it's actually a peristaltic pump. So this flexible tube is compressed by a roller onside this rotating part. So the ink is actively pumped from the underside of the head parking unit and pumped round up through this tube, the same tube. It outputs from this tube down here, which ends up in the foam receptacle. So yeah, as ink drains from the printhead while the system is switched off and the head is parked, it is actively pumped out and dumped into the sponge at the back. So I guess that's why they can't leave that process running forever. They have to have a counter that disables the printer once that sponge is likely to be full. So that explains why the thing works this way. But kind of annoying in the sense that a printer that should last forever doesn't last forever, simply because this sponge receptacle for the waste oil, waste ink, it gets filled up. It'd be nice if this fed into a removable tank, sort of waste ink tank, that you could periodically remove and just rinse under the tap, rather than this elaborate sponge arrangement that has a limited life. Anyway, so kind of fascinating. That's actually, let's say, this peristaltic pump. But yeah, there you go. So the thing that surprises me is that they couldn't arrange for this to drain just simply by gravity into a sponge or whatever waste ink receptacle. But as it is, they've decided to have this active pump to pump it up into the sponge unit at the back. I suppose this is quite low in the printer body, and this is the underside here against the ground or the table. So it is very low, but even so, I would have thought they could have had something that just picked it up under gravity rather than this elaborate arrangement to pump it out. Still, it's an interesting technology. So here's the pump, or primarily it's the drive for the whole machine. Various ratchets and cams here which operate different things. And this is the paper feed roller, which is interesting in itself actually, because it rubs against this and traps the paper between the two. But this is a one-way sprag type clutch, so it goes that way, but it won't go the other way. So I need to take that apart and just, out of curiosity, see how that works. Anyway, for now, this is the pickup for the ink, the waste ink from the head park, for want of a better phrase. So there's peristaltic pump around here. So the tube comes in this side, does a full circle, and then out the other side. It's okay. Ah, there you go, yeah. So this roller here is what squeezes the tube and forces the ink back into the waste sponge. So pretty cool. You see these sort of peristaltic pumps on things like blood, dialysis machines and heart bypass machines, that sort of thing. Beautifully simple pump, just with the roller rotating, squeezing the tube flat and just forcing the liquid inside around the tube. So there's no sort of contamination between the outside world and what's inside the tube. So nice for the medical applications, for instance, where you don't want that sort of thing. but also in other places as well. You find them occasionally. I didn't expect to find it in an Epson EcoTank printer, but there you go. Clever stuff. Nice little dogs in there to retain the tube. Just pull that out. Soft silicon tube, I feel of it. And there's detail even within this drive mechanism. There's these two steel coil springs, which mean that this section here, which is also a separate part, is it? Maybe not. Maybe it's molded into this. It is a separate part because this axle is separate from the circular portion. But yeah, so that moves against the springs. So this whole circular part is spring-loaded to keep this roller, which is also on a quadrant here, which is a wedge. So that wedges it in to crush the tube, apply the spring pressure, and make sure that the tube is completely flattened so that it pumps properly. So again, lots of parts. Remarkable, really. I'm really surprised that they went to this length just to get the oil drained away from the printhead park, especially when they could have used gravity with a bit of thought. Instead, they've gone for this elaborate arrangement with many parts just to get the oil, sorry, the oil, I keep saying oil, I mean ink, just to get the waste ink cleared away. So I'm kind of fascinated to know why this head part, print head park is so elaborate. And there's a spring underneath it which is pushing it upwards against the underside of the print head. There's this flexible rubber wiper here, so I guess it clears the head as the head comes in, get wiped and then park here with this kind of flexible rubber surround. I don't know why this metallic part is here. Oops, just gouge it out. Interesting. There's no obvious reason for that, but there's quite a quite elaborate. You can see that. I guess that's laser cut. I mean, it's definitely metal. I'm assuming it's steel. Let me just. Yeah, it's not magnetic. So it could be stainless steel, I would think. It's pretty stiff. Not aluminium. So I wonder why they think they need that. That's an expensive part. And underneath, this is just a sponge held on two pins that are part of the moulding underneath. So there's just a sponge. And here's a little ink receptacle underneath. So two pins just to locate the sponge and to locate this grid. And there's then the outlet, which is there, which just goes straight through to the underside. Just for completeness, this is the printhead. So this whole unit has the four feed pipes for the ink, black, and the three primary colours, or negative primary colours. There's a little sensor here that picks up on the graduated, what's the word, tape. There's a tape that runs through here, a little LED sensor that works out where it is. And this is the printhead. So again, an amazing feat of engineering. I mean, it just looks like a flat surface, but there's actually microscopic holes in that. inkjet technology, bubble jet, to project the ink onto the paper. So stunning. But that printhead parks on the little receptacle that we saw, and any excess ink is drawn or drips off and then is drawn off by that peristaltic pump. So yeah, stunning stuff. I mean, I take it for granted that the amount of engineering that's gone into this, just that little printhead is extraordinary.